Okay, in this video we're going to continue to look at rational equations, and this is part 2 of 2 videos, so make sure you watch part 1 before you watch this video. And the first example we're going to look at is 1 over 2x subtract 2 over 5x equals a half. The major difference between the type of equations in this video compared to the first video is here we have multiple fractions on one or both sides of the equal sign. In the first video we had a fraction equals a fraction, and you could just cross multiply and solve. Well, when you have multiple fractions, like in this part, we have 2 fractions on the left side of the equation, you can't just cross multiply. So you have 2 options in solving an equation like this. The first option is subtract or add these 2 equations together by getting common denominators. Okay, so the first fraction has a denominator of 2x, the second fraction has a denominator of 5x, that's going to be a least common denominator of 10x, so we can multiply our first fraction by 5 over 5, our second fraction by 2 over 2, and we'll go ahead and leave the 1/2 alone. So our first fraction is going to be 5 over 10x, subtract 4 over 10x, and that equals a half. Notice that 5 over 10x is the same as what we originally started with, 4 over 10x is the same as what we originally started with, so we're maintaining value through the process. When we subtract these 2 fractions, 5 subtract 4 is 1, the denominators remain unchanged. Now, since we did all that work, now we can go ahead and do like we did in the first video and just cross multiply and solve. So 10x times 1 is 10x, 1 times 2 is just 2, and when we divide both sides by 10, we get 2/10, which just gives us an answer of 1/5. I went ahead and checked this answer before doing this video and verified that it does work, just to save a little bit of time. But remember, in rational equations, we always want to sub our answer back into the original problem to verify that we don't have any extraneous solutions. There is a second way to solving these problems. So I'm going to do this problem the second way. Instead of getting common denominators and adding or subtracting, you can also multiply the whole equation by the least common denominator, kind of like we do on our WCK problems. So the first fraction has a denominator of 2x, the second has a denominator of 5x, and the third fraction has a denominator of 2. Well, the least common denominator for 2 and 5 is 10, and we're going to go ahead and put an x in there since 2 of the 3 terms have an x. Remember, when you multiply a whole number into a fraction, you only multiply into the numerator because this is really 10x over 1. So our first fraction will become 10x over 2x. Our second fraction will become 20x over 5x. And our third fraction will become 10x over 2. This is going to simplify to be 5. This is going to simplify to be 4. And this is going to simplify to be 5x. So now we have a very easy equation to solve from here. 5 subtract 4 is 1. And when we divide both sides by 5, we get the same exact answer we did doing the problem with the other method. So, I personally like this method better. I just think it's a little quicker. Typically, I won't show this work right here. I can see what's going to cancel out, but it's okay. If you feel a little uncomfortable, show this work at the beginning. Okay, so let's try another example. 4 over x subtract 3 over x plus 1 equals 1. I'm going to do this problem just with the LCD method, the least common denominator. If you want to work this out by getting the 2 fractions together and cross multiplying, that's fine as well. You can pause the video and see if you get the same answer. So, the least common denominator in this problem, our first fraction has a denominator of x, the second fraction has a denominator of x plus 1, and 1 is just 1 over 1, so we're not going to even regard that. So my least common denominator is x times x plus 1. Remember, this x is not the same thing as this x because x plus 1, it's a binomial expression together. So if we multiply everything by this, all of our fractions will cancel out. So I'll go ahead and show all the work. So our first fraction, the 4 will remain, and we're multiplying in x times x plus 1. Our second fraction, the 3 will still be there, and also what we're multiplying in. And the 1, well, 1 times anything is what you're multiplying in. Okay, so in our first fraction, the x's will cancel. In our second fraction, the x plus 1's will cancel, and nothing here will cancel because it's not a fraction. So here, we're left with 4 times x plus 1, which will just give us 4x plus 4. Here we're just left with 3x. And here, if we distribute in our x, that will give us x squared plus x. So we can now see that we're left with a quadratic. If we simplify the left side of the equation, 4x subtract 3x is just x. And since we're solving a quadratic, we want to get everything to one side and set it equal to 0. It's always easier to keep the quadratic term positive. So I'm going to move the x over by subtraction. And when we do that, these two x's will cancel each other out. So I can just bring the 4 over by subtraction. Or I could just leave the 4 where it is and solve by square roots. So either way I solve the problem, I'm going to get the same answer, plus or minus 2. Okay, so what we need to do now is we need to double check that both of these answers work. Okay, so let's start with positive 2. If we put 2 in for x, well, 4 over 2 is 2. 2 plus 1 is 3. 3 divided by 3 is 1, and we're subtracting. 2 minus 1 does give us 1, so the answer of positive 2 does work. Now let's go ahead and sub in negative 2 to make sure it works. When we sub in negative 2, 4 over negative 2 is negative 2. Negative 2 plus 1 is negative 1. 3 divided by negative 1 is negative 3. And since we're subtracting, negative 2 subtract negative 3 is also 1. So the answer of negative 2 also works. So this problem has two solutions, positive 2 and negative 2. So I told you guys I'd throw a meme in here for you. And most of you guys say this in class anyway, so we know that's a true statement. So we're going to do one more example, and it will be a little more challenging. So we have x over x plus 3, subtract x over x subtract 3, equals x squared plus 9 over x squared minus 9. Okay, so we're going to do this problem by multiplying everything by the LCD. First thing you're going to want to do is factor out the last denominator so we can figure out what the least common denominator will be. We can't do anything with the first two fractions at the moment. X squared plus 9 will not simplify at all. Well, x squared plus 9 is x plus 3, x minus 3. So if we look at all of our denominators, we have x plus 3, x minus 3, and we have both of those. It looks like the least common denominator in this problem is just going to be x plus 3, x minus 3. Or you could write it out as x squared subtract 9 if you want to do it that way. Okay, so I'll go ahead and show all the work so we can see what's going to cancel out. So our first fraction, the x is still going to be there. And we're multiplying in x plus 3, x subtract 3. And we had an x plus 3 in our denominator. The second fraction, the x is still there. And we're multiplying in x plus 3, x subtract 3. And there was an x subtract 3 in the denominator. And in our last fraction, we're going to have a lot of stuff in the numerator. We're going to have the x squared plus 9 that's already there. I'll go ahead and put that in parentheses so I can differentiate all the stuff that's here. And once again, if you're not showing this step, you're going to get the problem done quicker than me. And the more experience you get with these kind of equations, you can really skip showing all this work. All right, so in our first fraction, the x plus 3's will cancel. In our second fraction, the x subtract 3's will cancel. And in our third fraction, the x plus 3 and the x subtract 3 will also cancel. So we are going to be left with x times x subtract 3, which if we simplify it will give us x squared subtract 3x. Here, we'll have x squared plus 3x. I'm going to go ahead and put that in parentheses because we're subtracting the entire thing just to keep myself organized. And over here, we are left with x squared plus 9. So now we have a problem without any fractions. So when we simplify the left side, I'll go ahead and distribute out the negative. So the x squared becomes negative. The 3x becomes negative as well. Okay, so on the right side of our equation, the x squares are going to cancel each other out. The negative 3x's will not, because they're both negative. That will give you negative 6x. Okay, and since we have a quadratic, we're going to get the 6x to the other side by adding it. And this is a factorable equation. It's just x plus 3 or x plus 3 squared, which will give you one answer of negative 3. Okay, so we need to go ahead now and double check that negative 3 works. If we look back at the original problem, though, we're going to see an issue right away. As soon as I sub in negative 3 to the first fraction, negative 3 plus 3 gives us 0. That's going to make the first fraction undefined, which automatically is going to make the answer of negative 3 not work. So, since we only arrived at one answer in this problem and it didn't work, this is an extraneous solution, and this problem has no solution.